A window is in the form of a rectangle surmounted by semicircle. If the total perimeter of the window is 9 meter, can we find the radius of semicircle for the greatest window area? Let's do this problem. Let's draw the rectangle that forms the part of the window. And we did draw the rectangle. Now we want to surmount a semicircle above this rectangle. Let OA, BC be the rectangle. So we should draw a semicircle with diameter being BC. Let's draw the semicircle. And we did draw a semicircle. Now obvious question is we want to maximize the area of the window, but we want to make sure that perimeter of the window is always equal to 9 meter. We want the maximum area and the perimeter is equal to 9 meter. Now let OA be x unit. So CB, the diameter is exactly equal to x unit. So let's say the radius must be equal to x by 2. The radius of the semicircle must be equal to x by 2. We want to make sure that perimeter equal to 9 unit. Perimeter, the outer boundary must be equal to x plus OC. Let OC be L. Opposite side of rectangle are equal, so AB will also be equal to L. So x plus L plus semicircular arc. In case of circle, the perimeter is given by 2 pi r, but in case of semicircular arc, perimeter is given by pi r, and we got r equal to x by 2. And we want to make sure that perimeter equal to 9 unit, so x plus 2L plus pi by 2x equal to 9 unit. Can we solve for L? Of course, 2L equal to 9 minus x minus pi by 2x. So L equal to 9 by 2 minus x by 2 minus pi by 4 times x. As you said, we want to maximize the area. Let us find the formula for area. Area of the window is equal to area of rectangle, that's L times x, plus area of semicircle. Area of circle is pi r square. Area of semicircle is half of pi r square, and in this case we got r equal to x by 2. Further, L equal to 9 by 2 minus x by 2 minus pi by 4x. And this can be simplified as pi by 8 x square. Now you see that area, let's just write A for area. It is a function of x and it is just a polynomial. You see the right hand side is just a polynomial. Polynomial are continuous, differentiable. So if A poses a maximum, at the point of maxima, derivative should be equal to 0. Let's find dA dx. So we'll be using calculus to maximize the area. dA dx equal to, let's write area, it's polynomial expression, 9 by 2 minus x square by 2 minus pi by 4 x square plus pi by 8 x square. So we can differentiate it. Of course, we can simplify this one as well. Derivative of 9 by 2 is 0. Derivative of x square is 2x. So 2x by 2 minus pi by 4 times 2x plus pi by 8 times 2x. That's equal to minus x minus pi by 2 plus pi by 4x. Oh, I made a mistake. 9 by 2 times x is 9 by 2x. And if I differentiate 9 by 2x, then I get 9 by 2. So 9 by 2 minus x minus pi by 2x plus pi by 4. That's equal to 9 by 2 minus x minus pi by 4 x. Okay, as we said, we want the derivative to be equal to 0 if we want the maximum value. So dA dx equal to 0 if 9 by 2 minus x minus pi by 4x equal to 0. That can be written as, we take x common, pi by 4 plus 1 is equal to 9 by 2. So x must be equal to 9 times 4 divided by pi plus 4 times half. And so x equal to 18 by pi plus 4. As we said, we want to maximize it, so we should compute double derivative. So to know whether x equal to 18 by pi by 4 is a point of maxima or point of minima. d2a by dx square. Derivative of 9 by 2 is 0. Derivative of minus x is minus 1. Derivative of minus pi by 4x is minus pi by 4, which is negative. So we can say that x equal to 18 by pi plus 4 is a point of maxima, is a point of maxima. Now can we find the maximum area of the window? So we got x equal to 18 by pi plus 4. But you see that radius equal to half of x. So r equal to 18 by pi plus 4. That has to be halved. And so the radius equal to 9 by pi plus 4. The question is asking for find the radius of semicircle, and we did find. Now let's find the greatest area as well. So the area when r equal to 9 by pi by 4 is a equal to, let's write the formula, 9 by 2 minus x by 2 minus pi by 4x times x plus pi by 8 times x square. We got x equal to 18 by pi by 4, so 9 by 2 minus 18 by pi by 4, x by 2 is 9 by pi by 4 minus pi by 4 times 18 by pi by 4 to be multiplied by x. X is 18 by pi by 4 plus pi by 8x square. Let's simplify it out. We simply take the LCM. LCM is 4 times pi plus 4. So I should multiply 9 by 2 times pi plus 4 minus 9 times 4 minus 18 pi. Everything to be multiplied by 18 by pi plus 4 plus pi by 8 times x square. Again x equal to 18 by pi plus 4. 18 by pi plus 4 whole thing square. Observe that we can cancel 18 pi out, and then we can subtract 9 times 2 times 4 with 9 times 4 to obtain just 9 times 4, that 36. 36 by 4 times pi plus 4 whole thing square to be multiplied by 18 plus pi by 8 times 18 times 18 by pi plus 4 whole thing square. observe that we can take 18 by pi plus 4 whole thing square common. When we take 18 by pi plus 4 whole thing square common, we will be just left out with 9 plus pi by 8 times 18. Yes, 18 by pi plus 4 whole thing square we took common, so pi by 8, 18. 18 by pi plus 4 whole thing square common, we'll just left out with 9. Now we can cancel it out. 2 times 4 is 8, 2 times 9 is 18. So this is equal to 36 plus 9 pi divided by 4 to be multiplied by 18 by pi plus 4 whole thing square. Again we can take 9 common and we will be left out with pi plus 4. We can cancel pi plus 4. 18 by pi plus 4 whole thing square, let's write as it is. 4, let's write as it is. If we cancel pi plus 4, we will be left out with simpler expression. We can cancel by 2 as well. So that's equal to 81 by 2 pi plus 4. That's the maximum possible area of the window.